Thank you. Thank you. Hello, everybody. My name is Tsion, and I'm a PhD student at the King's College London with Dr. Wahi. And I'm going to talk about clustering of energy performance data in the context of energy poverty. Thank you all for being here. So as you all know, the climate crisis, I think you're all here for the same reason, more or less. And yeah, the residents have a massive impact on that directly/indirectly through just dwellings they live in or how they consume those dwellings, especially energy. So in the UK, for example, 41% can be connected to those buildings, either in their construction or in the energy, and worldwide a similar number is 37% roughly. And here, obviously, we try to tackle this through energy transition, but at the same time, we've got a multifaceted problem. So on top of just trying to, move to renewable energy, we also have that overlapping with energy poverty. So the access to energy for residents, and especially in the UK, that comes on top of the aged housing stock and a massive reliance on gas heaters. Especially in the UK, the problem is more heating than cooling, and just overall pre-existing energy poverty. And here, energy poverty in general describes the concept of, it's an evolving subject, I would say. So there's no one universal definition, but the most universal one I would say is the ability to just, remain an adequate temperature in one's dwelling. So the question here then is, how do we approach people who, need to remove renewable energy, but might be affected in a different way because energy poor? If you look at this, for example, there's no, as I said, common definition. One that we know is the 10% cost metric, where we look at, where we define total households as households that are they spend more than 10% of their remaining income after housing costs on energy. And here, for example, during the Ukraine war crisis in the UK, we had a massive spike because energy prices were not, and quite simply, they would spend more than 10% of their income on said energy. But if we use the government of England's definition, we get a very different picture, which is the dark blue line, which is quite steady even through that crisis, where we know that through experience, people were struggling. And that is because the government of England uses the so-called Lilly metric, where they filter for energy efficient households. So for them, energy poor households can only be households that have really bad energy efficiency rating. So generally speaking, there's different ways how to measure energy poverty, and they can be based on income, demand, efficiency, as I said, expenditure, housing standards. Some metrics like to include even things like appliances used and so forth. So what am I trying to do here? So I'm trying to cluster energy performance certificate data. So in the UK, you've got energy performance certificates that work quite similar, at least visually, as energy certificates we have for appliances like washing machines or fridges. And I tried to cluster that data to just have a deeper look at what commonalities there are, what differences, and potentially how we can identify energy poor households in that way. And then I think that could be a step forward because it means that we can define define energy poor households and depending on their situation instead of coming top down with a more or less arbitrary 10% threshold. And for that, as I said, I'm using the government certificate database, which basically exists for most dwellings in England and Wales. Any building that is supposed to be sold or let has to have that certificate, and it includes 80 parameters, so it's very thorough. And here, I'm going to apply K-box typing and to cluster that data into Python package. And ideally, the next step, so far I've done it in a quite exemplary way. The next step, I would then extend this data set with this clustering, so we can use it in a generalized way where, depending on your location, and what group you belong to, we can potentially identify your risks to fall within a energy poverty category. But for now, I chose two boroughs in London, and one is Newham, one is Bank Chelsea, and I chose them just to be able to show major differences in how things are clustered. And one is very low income household, and one is a high income borough. Um, yeah, correspondingly, rents and differ as well, and fuel poverty levels, according to the government's statistic that I just summarized earlier, differ as well. So from that certificate database, I chose these 5 parameters for the clustering, which generally speaking, to show you the common denominator in how to identify energy poor households. So that includes the property type, flats or houses, and that's quite mixed in the UK, or especially in England and London. The floor area, said efficiency rating, expenditure, and the demand efficiency. Just yeah, a quick step in the data preprocessing. So of course I normalized data. I checked for multicollinearity, and I used several indexes to define how many clusters we want. And yeah, I came up with the clusters of 3. So I'm always looking for 3 clusters in the database. To my results. So I think it's more than obvious that the results very much depending on the borough you look at. The high income borough, the borough of Kensington and Chelsea, we can see that the clusters have vary in size significantly. So the biggest cluster is much bigger than the smallest cluster. And for Newham, which is the low income borough, there's a more even spread, even distribution across all the clusters, and I'll come to that in a second. So one of the commonalities you can see is that said big clusters, for example, the biggest cluster for Newham, which was the low income cluster, and low income borough. Here, the biggest cluster is defined by a very vulnerable group. So a group with a high floor area, but simultaneously low efficiency rating and high energy expenditure. As you can see here, the difference between energy efficiency rating between the biggest high income group and the biggest low income group is quite significant, over 10 percentage points. And the same goes for energy expenditure. There's a very big difference, where the low income groups, which is the vulnerable group, spends more in that cluster. And on the other hand, though, in Kensington Chelsea, which is the high income borough, the biggest group here is a group that lives fairly comfortable. So they've got the best efficiency rating, they've got the best demand efficiency, and spend compared to the rest, the other residents in that borough, they spend less on energy. Another conclusion we could draw from the data is that, especially in Kensington and Chelsea, the borough where the distribution was very uneven, there's one specific cluster, the smallest cluster, which only represents 14 dwellings in the borough. That specific cluster represents villas. So again, fairly comfortable living people, where even though their energy costs are very high, and floor areas correspondingly is also very high because they live in villas, they still are in a not so vulnerable group, even though in other statistics they might come up as one because of the high energy expenditure. And furthermore, in Kensington Chelsea, so the high income borough, generally speaking, there was a high energy expenditure and a worse efficiency rate. Lastly, I would like to highlight this results where we can see that houses were always uniquely clustered. So even though we have 53 clusters, there was always one specific cluster per house, which might imply that it's got its own characteristics, especially in Newham, in the low-income borough. The household defined the cluster of finance houses makes up 92%. So that's fairly predictable, I think. Whereas again, the difference here is in Newham in the low income borough, that describes the vulnerable group, the one that potentially lives above their means, one could say, because they live in a high floor area, high floor house, or can't compensate with income. And the opposite for the high income borough, where the house is the not so vulnerable group. Yes, so to wrap it up, so there are several limitations. Obviously, it's quite exemplary. So I've only looked at two boroughs so far, and two London boroughs. London is very different in socioeconomic makeup compared with the rest of the UK. There's slight disparities between low and income households. You've got low income boroughs, especially. So in the next step, I would like to expand this across the whole country and automate it so we can compare different scales. Furthermore, this is all based on the government's database. So any assumptions they make, obviously, like indirectly copy them as well. And I've selected 5 parameters, which I do not find problematic though, because they are quite common. And yeah, data preprocessing is mostly concerning the numerical parameters, and I've got 1 or 2 categorical parameters as well. So to sum it up, as I said, we've got a high income and a low income borough. The quality metrics from the government are not too different. However, the efficiency rates are very different. So we can assume, I think it's safe to assume that in the high income database, the high income borough, people are potentially able to compensate through the high income, which then is not reflected in the government statistic, which focuses on the efficiency rating, where many of the low efficiency rated houses in the high income borough would be included, even though they are able to compensate. That's so much to my presentation. Thank you very much.
Do you have a sense of the pattern? Maybe
Yeah.
So maybe a set of the car
Yeah.
are consistent. Do you think that's profiles of like you're describing?
Yeah.
And then the topics change like profile.
Yeah. It's a very good question. I think so. For now, I want to stick to those 5 parameters, but their makeup will change significantly because, for example, in London, it's very common that social housing is a mix of trends, also big flat apartment towers. Whereas the moment you leave, 2 or 3 cities, you should have a high degree of social housing, but you go to rather small flats, rather big houses. So does make a difference. But the thing is, so far, our analysis is concerning relative within your region. So that would be, it's basically delta then, where that's automatically counted for then, you'd say. Yeah.
So I assume one of the other issues that you look at is, can you get more energy efficiency in the energy poverty areas?
Yeah.
And how do you do that from the policy standpoint?
So I think partly my work's motivated by maybe an initial finding that potentially getting more energy efficiency to poverty areas does not help as much as hoping for. Because, for example, here in Newham and the low income housing regions, energy efficiency is much higher than the high income region, and not much higher, but it is higher. But at the same time, fuel poverty is. That might be due to a higher prevalence of social housing, with the government cares for the insulation, cares for efficiency rating, but you still live in energy poverty because you don't have the income to compensate for rising energy bills. So that is partly why I'm motivated to do this work, where I don't solely, I'm situated in health engineering, so it was quite tempting to just go straight for energy efficiency measures, but I realized, I think it has to be more looking at the bigger picture. Okay. Thank you very much.
We have our talk before a break, electrical tariff, a barrier for the development of renewable energies in Colombia.